So you've got your little setup here, and you've noticed that they've given you h equals 10 this time. What they haven't given you is the angle. You're right, we're not going to use h in the actual formula like you did last time. What we're going to use h for is to find out what the angle is, because we need that. You're going to be accelerating a lot faster down a big angle here than you would a small angle, so it matters. So what we're going to do is remember that this is a right angle triangle because the height is straight up. This is my hypotenuse, and this being across from the angle I'm interested in is my opposite side. If I have hypotenuse and opposite, I'm going to use the sine ratio, so I'm going to set up my little sine triangle. Sine is opposite over hypotenuse, and if I'm solving for sine, then I'm going to go opposite over hypotenuse. So I'm going to go second function sine, opposite over hypotenuse. In this case, that's second function sine of 10 over 20, which is 0.5, which will give me 30 degrees. So you should be able to plug that in your calculator. We learned that stuff in grade 10. It's just basic trigonometry. Okay, and then now that I have that degree, I can set up my triangle underneath here talking about my free body diagram. So force of gravity is pulling straight down on this guy, and the normal force is pushing up here, and the force of friction is pulling this down. Now, the mass for those is the same, so we can, instead of dealing with the force of gravity, we can deal with the acceleration. So I don't have a mass here, I have the acceleration. I know they're going to be correlating, and acceleration is a vector quantity. So I can just go g instead of fg, and my acceleration is going to be that side. I know that 30 degrees is here, so it's going to be here because those are similar triangles. And then I could just go solve that side of the triangle here, which is the opposite side to my known angle, because there's my right angle and this is my hypotenuse, which is, we're rounding it off to 10 instead of using 9.8. So now I have a triangle, where I'm looking for the opposite side. My opposite is going to be equal to sine of my 30 degrees times my hypotenuse, which is 10. So I'm looking at the green triangle here. And I know that this is 0.5, so 0.5 times 10 is just going to be 5. And because that is, this is our acceleration, there. It's just rounded off 5 meters per second squared because it's acceleration. So we've got our acceleration, and then they give you this handy little derived formula for time, and you've already used that once, so it's square root of 2d over a, and that's just a derivation of the d equals v initial times t plus 1/2 at squared that we would have used in, actually I think we use it a little bit in science 10 and then again in physics 11, physics 12. So we just plug in our numbers. I'll write it up here so it's a little easier to see. T equals the square root of 2 times 20 over acceleration, which is 5. So 2 times 20 is 40, divided by 5 is 8, so t equals the square root of 8, which should be about 2.9. Use our handy dandy calculator, and square root of 8 is 2.8, close enough. They've already messed with our accuracy, making 9.8 equal to 10, so that's 2.8 seconds. So yeah, that's pretty much it. Most of these questions you're going to need to draw a free body diagram, making sure that you remember that the force of gravity goes straight down. Remember that this is your, if you're dealing with forces, will be your normal force because it's pressing against the surface that it's wanting to drop through. and you're going to have force of friction come into play at some point, and that's going to be using for the normal force, because your force of friction, which will be acting backwards, is going to be equal to your normal force times mu. So this is going to be something that you're going to have to figure into your equations as soon as they start telling you that friction is involved. If friction's not involved, really don't deal with this one. You're just going to set it up the way we did just now.